Hello, so let's start with a new tutorial on AWS Data Pipeline. Now, AWS Data Pipeline is a web service that is used to automate the movement and transformation of data. With AWS Data Pipeline, you can define data-driven workflows so that tasks can be dependent on the successful completion of previous tasks. The data pipeline is a series of processing steps to prepare enterprises' data for analysis. Organizations have a large volume of data from various sources like applications, Internet of Things, devices, and other digital channels. However, raw data is useless. It must be moved, sorted, filtered, reformatted, and analyzed for business intelligence. A data pipeline includes various technologies to verify, summarize, and find patterns in data to inform business decisions. Well-organized data pipeline support various big data projects such as data visualization, exploratory data analysis, and machine learning tasks. So we have seen that AWS Data Pipeline is a web service that can be used to automate the movement of transformation of data, which is necessary to keep movement of data under control. With AWS Data Pipeline, one can define data-driven workflows so that tasks can be dependent on the successful completion of previous tasks. It is important to define the data transformation, and AWS Data Pipeline enforces the logic that you have set up. The following components of AWS Data Pipeline work together to manage your data. A pipeline definition specifies the business logic of your data management. A pipeline schedules and runs tasks by creating Amazon EC2 instances to perform the defined work activities. You upload your pipeline definition to the pipeline and then activate the pipeline. You can edit the pipeline definition for a running pipeline and activate the pipeline again for it to take effect. You can deactivate the pipeline, modify a data source, and then activate the pipeline again. When you are finished with your pipeline, you can delete it. Tasks runner call for task and then performs these tasks. For example, task runner could copy log files for Amazon S3 and launch Amazon EMR clusters. Task runner is installed and runs automatically on resources created by your pipeline definition. You can write custom task runner application, or you can use the task runner application that is provided by AWS Data Pipeline. For example, you can use AWS Data Pipeline to archive your web server's logs to Amazon simple storage service, that is Amazon S3, each day and then run weekly Amazon EMR, that is Amazon EMR cluster over these logs to generate traffic reports. AWS Data Pipeline schedules the daily tasks to copy data and the weekly tasks to launch the Amazon EMR cluster. AWS Data Pipeline also ensures that Amazon EMR waits for the final days data to be uploaded to Amazon S3 before it begins this analysis. Even if there is an unforeseen delay in uploading the logs. Access AWS Data Pipeline. You can create, access, and manage your pipelines using any of the following interfaces. AWS Management Console provides website interface that you can use to access AWS Data Pipeline. AWS Command Line Interface, that is AWS CLI, provides commands for a broad set of AWS services, including AWS Data Pipeline, and is supported on Windows, Mac OS, and Linux. For more information about installing the AWS CLI, see AWS Command Line Interface. AWS SDKs provides language-specific APIs and take care of many of the connection details, such as calculating signatures, handling request retries, and error handling. Query API provides low-level APIs that can call using HTTPS request. Using the query API is the most direct way to access AWS data pipeline, but it requires that your application handle low-level details such as generating the hash to sign the request and error handling. What are the benefits of the data pipeline? Data pipeline lets you integrate data from different sources and transform it for analysis. They remove data silos and make your data analytics more reliable and accurate. Here are some key benefits of a data pipeline. Improved data quality. Data pipelines clean and refine raw data, improving the usefulness for end users. They standardize formats for fields like dates and phone numbers while checking for input errors. They also remove redundancy and ensure consistent data quality across the organization. Efficient data processing. Data engineers have to perform many repetitive tasks while transforming and loading data. Data pipelines allow them to automate data transformation tasks and focus instead on finding the best business insights. Data pipeline also help data engineers more quickly process raw data that loses value over time. Comprehensive data integration. A data pipeline abstracts data transformation functions to integrate data sets from disparate sources. It can cross-check values of the same data from multiple sources and fix inconsistencies. For example, imagine that the same customer makes a purchase from our e-commerce platform and your digital service. However, they misspell their name of the digital service. The pipeline can fix this inconsistency before sending the data for analytics. How does a data pipeline work? Just like a water pipeline moves water from reservoir to your taps, a data pipeline moves data from collection point to storage. A data pipeline extracts data from its source, makes changes, then saves it in a specific destination. We explain the critical component of data pipeline architecture below. Data sources. A data source can be an application, a device, or another database. Disparate sources may push data into pipeline. The pipeline may also extract data point using an API call, webhook, or a data duplication process. You can synchronize data extraction for real-time processing or collect data in a scheduled interval from your data sources. Transformations. As raw data flows through the pipeline, it changes to become more useful for business intelligence. Transformations are operations such as sorting, or reformatting, deduplication, verification, and validation that change the data. Your pipeline can filter, summarize, or process data to meet your analysis requirement. Dependencies. As changes happen sequentially, specific dependencies may exist that reduce the speed of moving data in the pipeline. There are two main types of dependencies, technical and business. For example, if the pipeline has to wait for a central queue to fill up before processing, it's technical dependency. Conversely, if the pipeline has to pause until another business unit cross-verifies the data, it's business dependency. Destinations. The endpoint of your data pipeline can be a data warehouse, data lake, or another business intelligence or data analysis application. Sometimes the destination is also called a data sink. What are the types of data pipelines? There are two main types of data pipelines: the stream processing pipelines and batch processing pipelines. Let's discuss one by one. That is the stream processing pipelines. A data stream is a continuous increment sequence of small-sized data packets. It usually represents a series of events occurring in a given period. For example, a data stream could show sensor data containing measurements over the last hour. A single action, like a financial transaction, can also be called an event. Streaming pipelines processes a series of events for real-time analytics. Streaming data requires low latency and high fault tolerance. Your data pipeline should be able to process data even if some data packets are lost or arrive in a different order than expected. Batch processing pipelines. Batch processing data pipelines process and store data in large volumes or batches. They are suitable for occasional high-volume tasks like monthly accounting, etc. The data pipeline contains a series of sequenced commands, and every command is run on the entire batch of data. The data pipeline gives the output of one command as the input of the following command. After all data transformations are complete, the pipeline loads the entire batch into a cloud data warehouse or another similar data store. Difference between batch and stream data pipelines. Batch processing pipelines run frequently and typically during off-peak hours. They require high computing power for a short period when they run. In contrast, stream processing pipelines run continuously but require low computing power. Instead, they need reliable, low latency network connections. Thank you.